We'll talk about Dora in this video. So let's get started. How Dora works. Dynamic Host Configuration Protocol DHCP uses the Dora Dynamic Host Control Configuration Protocol is the protocol of the application layer. It is used to provide subnet mask, router address, DNS address, and vendor class identifier. In fact, DHCP provides an automatic IP address to hosts which want to connect to a network. Dora is the process that is used by DHCP. Dora helps in providing an IP address to hosts or client machines. Dora is the process that follows some steps between the server and client. It gets the IP address from the centralized server. It consists of 4 stages: discover, offer, request, acknowledge. Now let's see what happens when DHCP clients request a DHCP server an IP address. Let's see what messages are exchanged between them in the process. Note, in the layer, DHCP messages are always broadcast in the data link layer. Also, DHCP messages are broadcast. Step 1. DHCP discover message. This is the first message in the Dora process which helps in finding the DHCP server of the network. DHCP client will find the server by sending DHCP discover message. The broadcast message is sent to the network. As the DHCP client doesn't know the IP address of the server, so the message is broadcast with the destination IP address is 255.255.255.255 and the source IP will be 0.0.0.0. As the client doesn't have any IP address, here the DHCP discover message in the data link layer and network layer is always broadcast. Source IP address, destination IP address, source MAC address of DHCP clients, destination MAC address which is default. Step 2. This DHCP offer message. DHCP server receives the discover message and it replaces the DHCP client with the DHCP offer request. The server sends a DHCP offer message with filled information. It has information about the IP address and duration of the time that a host can use. Here, destination IP address will be 255.255.255.255 as the DHCP client still doesn't have its IP address. But this DHCP offer message is always a broadcast in the network layer and unicast in the data link layer. Then source IP address of DHCP server, then destination IP address as follows, and source MAC address, destination MAC address. Step 3. DHCP request message. DHCP client sends the request message to the server when it receives a DHCP offer message from the server. This message tells the server that it accepts the IP address given by the server. Here, destination address will be 255.255.255.255, means it's again broadcast. The reason for this is there might be many DHCP server in the network, so the client may receive multiple offer messages and it will accept the request that reaches him first and send a broadcast message to eliminate other DHCP server. Here, source IP address will be 0.0.0.0 as the DHCP server hasn't yet assigned an IP address to the client. DHCP request message is also a broadcast message. Source IP address, destination IP address, source MAC address, destination MAC address. Step 4. DHCP acknowledge message. This is the last step or message in the Dora process. The DHCP server sends acknowledge message to the client when it receives the request message from the DHCP client. This message will contain the IP address and subnet mask that the server assigns to the client. Source IP address will be the IP address of the server. This will be again broadcast message as the destination IP address is 255.255.255.255, but it is unicast in the case of the data link layer. Source IP address, destination IP address, source MAC address, and destination MAC address as follows. What is APIPA? We'll talk about APIPA, automatic private IP addressing. APIPA stands for automatic private IP addressing. It is a feature for characteristic in operating system Windows, which enables computers to self-configure an IP address and subnet mask automatically when their DHCP Dynamic Host Configuration Protocol server isn't reachable. The IP address range for APIPA is 169.254.0.1 to 169.254.255.254, having 65,534 usable IP addresses, with the subnet mask of 255.255.0.0. Initially, the Internet Engineering Task Force (IETF) has reserved the IP for address block 169.254.0.0 subnet 16, 169.254.0.0 till 169.254.255.255 for linked local addressing. Due to the simultaneous use of IPv4 addresses of different scopes, traffic overload become high. The link local addresses are allocated to interface that is stateless in nature, such that communication will be established when not getting a response from DHCP server. After that, Microsoft refers to this address at configuration method as a automatic private IP addressing, APIPA. It starts when the user client is unable to find the data or information, then uses APIPA to configure the system with an IP address automatically. The APIPA provides the configuration to check for the presence of DHCP server in every 5 minutes, stated by Microsoft. If APIPA detects a DHCP server on the network configuration area, it stops and let run the DHCP server. That replaces APIPA with dynamically allocated addresses. Characteristics: communication can be established properly if not getting response from DHCP server. APIPA regulates the services by which always checking response and status of the main DHCP server in a specific period of time. Advantages: it can be used as a backup of DHCP because when DHCP stops working, then APIPA has the ability to assign IP to the networking hosts. It stops unwanted broadcasting. It uses ARP, Address Resolution Protocol, to confirm the address isn't currently in use. Disadvantages: APIPA IP addresses can slow your network. APIPA doesn't provide network gateway as DHCP does. Limitations: APIPA addresses are restricted for use in local area network. APIPA configured devices follows the peer-to-peer communication rule. Address Resolution Protocol: it is most computer programs application uses logical addressing IP addresses to send or receive messages. However, the actual communication happens over the physical address, MAC address, that is from the layer 2 of the OSI model. So our mission is to get destination MAC address, which helps in communicating with other devices. This is where ARP comes into the picture. Its functionality is to translate IP addresses to physical addresses. Address Resolution Protocol. The acronym ARP stands for Address Resolution Protocol, which is one of the most important protocols of the data link layer in the OSI model. It is responsible to find the hardware address of a host from a known IP address. There are three basic ARP terms: Address Resolution Protocol. Address Resolution Protocol is a layer 2 data link layer protocol that is used to find the MAC address of the known IP address. ARP request: it is a broadcast message generated by the source to find the destination MAC address. If the ARP is not resolved initially, ARP reply: it is a unicast message from destination to source device containing the destination MAC address. These steps include in the ARP process are as follows. When a source wants to send a packet to the destination device, then first the source ARP cache is checked if the ARP is resolved or not. If the ARP is not resolved, it puts the packet on hold and generates an ARP request. If the ARP is already resolved, then the packet will be delivered to the destination hosts. Third, the ARP request is broadcast all over the network. to find out that the device has a destination IP address. Note, if the destination is present in the same network, then ARP will find out destination MAC address. But if it is present in the different network, then ARP will find out default gateway MAC address. 4. When the device is having the destination IP address receives the ARP request, it updates its own ARP cache. 5. The destination host machine generates an ARP reply containing its own MAC address. 6. Now the device having the source IP address receives the ARP reply and update its ARP cache. 7. Since the both source and destination IP address and MAC addresses are available now, therefore the packet is delivered to the destination hosts. First, ARP cache. After resolving the MAC address, the ARP sends it to the source where it's stored in the table for the future reference. The subsequent communication can use the MAC address from the table. Second, ARP cache timeout. It indicates the time for which the MAC address in the ARP cache can reside. Third, ARP request. This is nothing but broadcasting a packet over the network to validate whether we came across the destination MAC address or not. First, the physical address of the sender. Second, the IP address of the sender. Third, the physical address of the receiver is default at IP address FFFFFFF or once. 4. The IP address of the receiver. 4. ARP response or reply. If it is this is a MAC address response that the resource receives from the destination, which aids in future communication of the data. Connect to PC, say A and B, with a cross cable. Now you can see the working of ARP by typing this command: A greater than sign, then ARP space dash A. There will be no entry in the table because they never communicated with each other. Then we'll type A and ping IP address of the destination, and then we'll get the reply. Now entries of the ARP table can be seen by typing the command. This is what the ARP table looks like.